So we talked about adding points to our geometry using VEX. So now the question is, what about lines? Because of course lines are going to be pretty useful to us. I'm just going to warn that this starts to get a bit complicated pretty fast. So I want to go extremely slow and explain things step by step here. So let's see here. So we want to add a new point to our geometry. And then we want to see if we can build a line between our points that we currently have and our new one here. So I could do, okay, add point to geometry handle 0, and let's go ahead and put it at 0, 3, 0 in as far as our position. So there we go. So we got our point, but now keep in mind there's actually a lot of points in that one there. So what I may want to do is actually go ahead and what I might want to do actually is go ahead and fuse these down, or actually what I'll probably end up doing will probably be faster is if I just run this once on for point number 0, and then I'll go ahead and make a new wrangle node to do the connection. Now, the important thing to keep in mind is that this is point number 100 right here. So I'm going to say that's important because when we start connecting them. And the reason why I added a new wrangle node here is because remember this one's only running on point number 0, and now I want all the points to run. So we've added our point. So now we could say AddPrim. So we're gonna add lines using the AddPrim function. So let's actually take a look at that. So if we look at our AddPrim VEX function, we can see that there's a couple different ways you could do it. We're actually going to go ahead and use this version right here, and what it will do is, of course, like so many, we need to tell it what geo handle. So we want geo handle 0, pretty standard, right? We want to add it to the first stream of geometry. Then this is an interesting parameter here, the type. In this case, and this does take a little bit of kind of just getting used to, I want to go ahead and make a polyline. That's kind of the most standard primitive that you'll make. And what it does is it basically will just create a line between 2 points, point 0 and point 1. Well, in our case, remember every single point has access to its own position, so we'll use that as the first point using @p. And then for the position of for the point, I'm sorry, not @p, @pt num, because as you can see this actually takes the integer. So position is a vector, right? So we actually want the point number here. And then we want to connect to point number 100 because that's our new point that we added. So there we go, we made it. Cool little Illuminati pyramid here. There's a couple problems with this though. I mean, as soon as I start to change, like let's say we do like 8 by 8, now all of a sudden our setup broke because there's no longer a point 100. So what we may want to end up doing is we know that this one will always add 1 point to the setup. So what we could do is we could create a variable. So we could say integer last point, and we know that the number of points. So we could go num points. I think maybe it's this. I think it's this. and then we could subtract 1 from it, because remember we're starting at 0, so if there's 25 points, which would be the value for num points, we want to actually subtract 1 to get the actual 1, and then we could do last point here. See, it didn't like what I did there. So let's see if we can figure out why. Implicit cast from float to int. Okay. So maybe I need to wrap this in an integer. I might be using the wrong attribute here. Let's try. It might be n PTS maybe, or maybe n points. So one thing that I'm kind of doing here that's not so great is I'm kind of guessing at what attribute we want. So I should actually look that up. So if I go to help and I go, I think it's endpoints. Let's see, endpoints. So it returns the number of points. Okay, so we can actually use the endpoints function. So we could say, hey, for geometry stream 0, how many points do you have? And then we could subtract 1 from that. There we go, and that worked. Sorry about the fumbling around there, but I think it's actually kind of useful for you guys to see me fumble, because it will show you that you don't need to get it right off the bat. But the reason this works is because now I'm counting the number of points in my geometry, and then I'm subtracting 1 from it, so that will get me the last point. Because remember, starting at 0, we want to subtract 1 to get the last point. So now the cool thing about this is now, if I change these, so for example, if I go like 6 by 6, my setup still works. So that's kind of an example where you want to avoid doing things like hard coding like a number here, if possible, because you have to kind of project, well, what if my setup changes? Will this work on multiple geometries? And you want to try to really kind of fireproof your setups to not break when those sorts of changes are made. And that's one thing that's kind of different about working in Houdini sometimes with other programs that aren't as procedural. The power in Houdini comes from the proceduralism, right? The fact that you can plug in any geometry stream and your setup should work in theory. Whereas if I was doing this for an individual piece, if the geometry changes at some point during production, I might have to do a lot of extra work if I hadn't done this procedurally. So let's review really quickly. AddPrim, the geometry stream, what type of primitive, which in this case is going to be a polyline, and then which points we want to connect, which is every point has its own point number, and then the last point in the setup. So that's one way we could do it. Another thing we could do is we can make a bunch of points along the normal. And for this, we actually don't need 2 wrangles. We can just do 1. So let's add a point, and let's go ahead and add it to geometry stream 0, and we'll start at your current position wherever you are. So you would start here, you would start here, you would start here, and we'll go ahead and add along the normal here. So we'll do at n. So let's see here. That didn't seem to. Oh, it added a bunch of points, but where did they go? Oh, because I'm still working on only on point number 0. So now they're all working. And so now I wanna go between them. So we'll go ahead and use AddPrim. We know we want to add it to geometry stream 0. We know we're working with a polyline. Um, we want to start at whatever your point number is. And we got a little bit of a problem here. What point do we want to connect it to? Well, uh, if I comment this out briefly, so we can kind of look at what we're doing. There's kind of an interesting question here. What is the point number of each of these points that we added here? Well, if we look here, we have some points, right? If we bypass this, we have 100 points, right? 0 to 99. But oh man, this is kind of weird, right? I mean, I guess we could say, um, take your current point number and maybe add 100 to that. Because if you're at 0, you would be at point 100. And assuming that the order that they added them in, well, that didn't work. Um, so, so, so now it starts to get a little tricky because how can we figure out which point to do here? Well, the best thing to do is to go ahead and when you added that point in the first place, go ahead and create an integer that will hold that information. So I'm going to create an integer. We'll call it PT. You know what? We'll do this actually a little bit more. We'll call this connecting point. And that'll be a little bit more explicit. So now if I go ahead and do an attribute called connecting point. Remember, this is my old trick where I put attributes on my geometry to kind of see stuff. So now that seemed to work. So if we look at our connecting point, it's interesting because they have maybe what we wouldn't necessarily think would be uh, these numbers are a little bit confusing, um, but basically the idea is that when it makes the thing to remember is that the add point function actually returns a integer, and you can use that to refer to the point that you're adding. So there's some integer here, and it looks like it was 0 a bunch of times, and then it was 100 a bunch of times. Looks like it was 100 for the first set of points, and then it was 0 for the next set because it didn't have anything to necessarily put there. But basically, this connecting point integer that I made will refer to that point that I added. So every single point has an integer value that it can refer to that is the connecting point. So when I use that as my last point to connect to with my AddPrim function, it ended up lining up basically. I think that was one of my worst explanations, but hopefully it kind of gets the idea across. Like let's see, if I do this, let's simplify this maybe. Let's do this on like a 3x3 grid or something like that, just to kind of simplify it and see what's going on here. So if we look at the first point, let's kind of go through and see what it did. So it basically said, okay, I'm going to make a new integer connecting point, and it's going to be that point that I added um, in the direction of the normal, and then um, it gave that uh, it gave that a value of 9. Well, to understand why it might do that, let's look at the point numbers before. So before it went from 0 to 8, right? So what the point function basically did is it said, oh, numbers 0 through 8 are already taken for my point number. So I'll just give the new point the number 9, right? Remember when we added the point in the previous video, we had 0 through 24 already taken up, and so then when we added a point, it became point number 25. So because this is working in parallel, each one of these points, when it looks at this code, it sees that numbers 0 through 8 have already been used, but number 9 is free. So basically, when I visualize it by creating this attribute and visualizing it on the geometry spreadsheet, that's why each one of these points says that its connecting point is 9. Because at the time that the points looked at this code, 9 was the number that was open. But it's confusing because what you can sometimes misinterpret this as is you can say, well, they're all connecting to point number 9. And that's not true. It's just that when each point made its connector point, at that time, the number 9 was open, right? So that's why there's no conflict here. Even though this says 9, they each kind of did it at the same time. So this one made its point, called it number 9, and connected to it. This point made its new point, called it number 9, and connected to it. This point made its new point, called it number 9, and connected to it, right? So that's kind of the pattern here. So anyway, I hope that wasn't too confusing, but again, we're kind of leveraging the parallelism of VEX here to kind of do things, procedurally. Because now, if I were to scale this up and make this, like, for example, like 10 by 10, now all of a sudden, we're good, same, no problems. And then if I were to maybe use a sphere, for example, and actually let's keep the sphere, see, we can even change the shape of our geometry and we still have no problems. So you can see, like, once you have your setup, it makes it really powerful being able to kind of switch in like this. So I'm going to go ahead and I'll increase the frequency a little bit just to get some more kind of going on. Okay, so that's how we can add lines. So the only kind of difference is we created an integer to store this point number as we added it, and then we were able to use it when we were making the line. So it's kind of one important concept to keep in mind. Now, so now the next thing that's going to happen is we're going to kind of create like a wave effect by kind of animating these lines with some noise. Now, the way that it's taught in the Joy of VEX lesson that I'm kind of basing this off of, I did a slightly different setup. So I want to point out that here we're going to delineate slightly from what the lesson says, but the concepts will be basically very similar. So let's see what we can do here. So the first thing we'll do is we're going to I'm going to create a new vector called noise, and I'm going to base that off of the normal, and then we're going to animate it by using the noise function. The way I'm going to animate it is I'm going to add this plus time here. So remember, time is an attribute that every point has access to, which is going to continuously change as we kind of frame through our animation, our timeline. So this kind of guarantees that this value will always be changing. And I want to go ahead and base it off of the normal. So again, I'm taking the normal and then I'm adding some number to it based off of the noise function. So actually, if I do v at noise, you guys know I like to use this as a teaching technique. So here's our attribute noise here. So as you can see, it's basically, so if we do, so it's taking the position, and then it's creating some noise based on that. So it's kind of offsetting it slightly. If we look at, for example, let's see here. So we're taking the normal and then we're adding noise based off of the position, and then we're animating it using the time variable. Hopefully that's clear. Now, one thing that's kind of interesting is if we kind of look at these values, notice that they kind of go between like about negative 0.5 and like 1.5, right? Roughly, right? And I didn't want that to happen. I wanted it to kind of be even across the board. Now, to explain why this is happening, well, first of all, without the, let's do, if we look at the normals, right, you see how they go between negative 1 and 1, right? If we kind of look at the normals, they all have like about a max value of 1 and a minimum value of negative 1. So for our starting point, we're dealing with numbers that are between negative 1 and 1. So one thing about the noise function that's important to understand is that it actually spits out values that are between 0 and 1. So if we're starting with numbers that are between negative 1 and 1, and we're adding numbers that are essentially between 0 and 1, you can see that our end result is going to be biased towards the positive direction, right? Because if we only add zeros and ones to things, then the things that were already positive are going to get more positive, right? That's just what's going to happen. And the things that were negative will move towards the positive direction. So I wanted to balance this out. So that's where we can use our fit function, which we learned about in previous lessons. We can use that to our advantage. So so I can go ahead and take this noise value that I created, and I can go ahead and fit it. So remember, the fit function, generally when we use it, we use 5 parameters. The first thing is, what do we want to fit? Well, I want to fit this noise attribute that I've created. We do the old min, which we know the noise function spits out numbers roughly between 0 and 1. So we'll go 0, and then old max 1. And I want my new numbers to be between negative 1 and 1, right, to try to balance it out. Because now, instead of, and actually, now that I'm looking at this, I probably should have done that before I added it. So let's do, so I wonder if it's too late to kind of change this. What if I do this, and then I know it's going to be between 0 and 1, and I want it to go between negative 1 and 1. This might work. It might mess it up. I'm not sure. Yeah. So now, if we look at our noise values, they're much more balanced in the sense that this first noise channel goes between positive 1.3 and negative 1.3. This one goes between positive 1.1 and about negative 1.1, and so on and so on. So these values are just going to be a little bit more balanced because I decided to use my fit function. So now what I can do is so I've got this vector basically that's floating somewhere above each one of these points in the normal direction. So if I turn my normals on, each point has kind of a vector that's floating somewhere in this kind of space. So now what I can do is I can say, let's make a vector called pause, and let's go ahead and take your normal and we'll add this noise attribute to it. And to see that in action, we can make an attribute for it. So again, I just want to check and make sure these are kind of spread evenly, so it looks like they are, so that's good. And then what I want to go ahead and do is I want each point to go ahead and make a new point at this position. And I'm going to go int connecting point because I know that's what I'm going to use this for. So I want to store it in an integer called connecting point, and I want to go ahead and add a point to geometry stream 0. And where do I want to add it? I want to add it. I want to start at your position, and then I want you to go ahead and add this position vector that I created, and that will get you at that place that I want you to go. And actually, I kind of misspoke earlier. I said that every point has a vector called noise that's floating somewhere above it. That's not exactly true. It has a vector that points in that direction, and then adding that to @p is what's going to actually be the point that's like floating above it in the direction of the normal. Whew, mouthful. Okay, so if we close this function, then we should have our connecting point. And so how do we connect our line? Well, we need a primitive. We're going to add it to geometry stream 0. We want to use a polyline. Go ahead and use your original point number, and then go ahead and use your connecting point that I made for you. And voila, it worked. So one thing that we can do to kind of help this a little bit is we can do times, and we can do a channel, and I'll call it line length, and we'll do 1. So what I can do here is I can use this to control kind of the length of the lines, just to get it maybe like a bit more, give it a bit more art direction. All right, so this was a lot of code. So let's back up and kind of review everything we did. Okay, so from a top-down perspective, we wanted to create a line that connects each point with a new point that's basically offset in the direction of the normal. And we want it to kind of animate, basically, right? So pretty cool effect. You could see I could see those medical animations, doing something like this. I actually kind of like this. This is pretty cool. But how do we do this? So first we said, okay, for example, if I get rid of this noise, and I just say if I do like this, um, then we've got our lines, but uh, it's not animating, right? So the idea is that um, each point found a connecting point that is above it in the direction of the normal, and basically that's kind of what this took care of. This line made the connecting point, right, by saying, hey, I want you to add a point, start at your normal position, and then add, in the direction of your normal, um, and then we have a line length channel that kind of controls it. And then here's where we actually make the line, um, by specifying that we want to, remember the last two parameters of this AddPrim function are the starting point and then kind of the end point. So by using this integer connecting point value, we were able to have each one kind of target the right one, and then we just start at your normal point number, right? So if this point was 0, go ahead and start at 0 and then connect to your connecting point. If this point was 1, go ahead and start from point number 1, connect to your end point. So for the animation though, we said, okay, well, let's make a vector called noise. That's going to be based on your normal direction, and we'll go ahead and create some offset with a noise function, and then we'll animate it using time, and it'll be based on your position. But then we kind of we said, well, we know that the noise function gives us numbers between 0 and 1, and we really want it to be between -1 and 1. Just to kind of show you, like, if you don't do this, like what kind of result you would get. I should probably show that why we wanted to do that. We get this thing where you see how it definitely has like a pretty significant bias in the positive direction. And I want it, maybe this is, you want like a chia pet, and like this is the effect you want, but I wanted it to not favor like one side. I wanted it to kind of have an equal opportunity to animate in every direction kind of thing. I didn't want to like have the lines mostly be pointing in the positive direction. So it's kind of interesting, right? Because just changing this number from 0 to -1 actually fixes that problem. It's actually kind of amazing that it does that, but it makes sense if we understand that essentially the noise function spits out numbers between 0 and 1. So when we think about the normals of a sphere, they're going to be evenly distributed between the positive and negative side of the number line. So if our noise values that we're adding are also kind of evenly distributed on the negative and positive side, then that will give us like a more even effect. So that's why I'm basically fitting these numbers between -1 and 1. This v at noise equals noise, I want to be really clear that this is for teaching purposes only. You don't need to make an attribute. I could get rid of that if I wanted to. Same thing with v at pause. That's just for teaching, so you can see the numbers. So we have our noise vector, and that's going to help us because we're going to create a position which is that noise but added to the normal. Now that I'm looking at this, I'm wondering if we even need this pause. Like, if we just do noise, will it work? Let's see. It kinda does. Kinda does, but it also is decidedly different than this. Trying to think why that is. So we have a noise based on this, and then we're adding it to the normal. I guess that makes sense. Because with the noise, that's kind of the offset amount. And then we're going to offset it in the normal direction to get the new position. I think is kind of what's going on there. But basically the bottom line is we now have a position um, that will be animated, right, because of this add time. So now when I'm making my points, right, if I don't have this plus pause here, if I just do, like, for example, like at n or something like that, it's not going to animate because this normal, if I just use plus at n, this value is never changing, right? These normals will stay the same. But if I do noise, because I am animating it up here, now you've got the kind of animation effect here. Or actually, I was going to use position. But basically, that is an example of how you can add lines to your geometry. Now, if this noise example was really confusing, maybe I would say, like, don't worry about it. I would say go back to the example where you're just connecting points from the grid to that one single point and creating the pyramid, and kind of go over that example over and over in your head until you kind of really understand what it means to make lines with this AddPrim function. And then once you really kind of have that down, then maybe take a look at this example again and see if you can kind of work out in your head why it works. But anyway, that is adding lines. I think that's a good point to cut off this video. I think that's plenty of information to digest, so we'll stop it.